Welcome to another electronics tutorial. In today's tutorial, I will be starting a new series. And in this series, I will be teaching you how to design electronic circuits from scratch. So what I'll be teaching you in this series is how to design electronic circuits. So this video is for beginners in electronics, for enthusiasts, for students that want to learn how to design electronic circuits from scratch. So because this is going to be a series, if you want to keep up with the series, then subscribe to my channel on YouTube if you are watching this video on YouTube. And when you do that, you turn on the notification bell so you don't miss out when I upload new videos. So without further ado, let's delve into the tutorial. What is electronic circuit design? I would say that electronic circuit design simply means manipulating the flow of electrons in a circuit with some electronic components to realize a desired result. Again, electronic circuit design means manipulating the flow of electrons in a circuit with some electronic components to realize a desired result. So if you have a desired result of a project and you want to bring it to life, then you can embark on electronic circuit design. And to do that, you have to use the components that are available to you to manipulate the flow of current within those components to realize your desired result. Let's say you want to build an inverter. You will then pick the various components required to build an inverter and then put them together and then have your inverter realized. So you have to understand the flow of current and you have to understand the various electronic components that are required for your circuit design. So that being said, it means that two things are essential in electronic circuit design, and they are your understanding of the flow of current and how to manipulate it in a circuit, and your knowledge about electronic components, your knowledge of the electronic component. So you need to know certain things, rules, laws, formulas, calculations that are needed to manipulate the flow of current. And you also need to know the various components and how they behave in a circuit and how to place them in a circuit. So let me explain further using a circuit. Now, on my screen, you can see that I have a circuit. And this circuit is a very simple circuit that every circuit designer knows. This is the first circuit project you will be given to make in your circuit design project as a beginner. The same way you are given a simple program to write when you are learning programming. If it is in programming, if it's a programming language you are learning, the first code you will be given to write is a code or a program to print hello world on the screen. And for us in hardware electronics, the first circuit we design is a circuit to turn on and turn off an LED. So we are going to use this circuit to explain a lot of things. So this circuit has a power source, which can be a battery or a DC power supply. And it has a switch, which when I close, it allows current to flow in the circuit. And when I open, it cuts off current supply in the circuit. And we also have a resistor. Here we are using 100 ohms resistor, and we have an LED which glows when the appropriate current and voltage enters it. And then we have some connection wires here, all right? Okay, now, from this circuit, you can see that when we cut off, or when we open this switch, no current flows in the circuit. But when we close the switch, current flows in the circuit. So this goes to show us that for current to flow in a circuit, there must be a path created for that current to move and return back to its source. So in this case, the source of the current is this power supply here, and current flows from the positive terminal of this power source here, then pass through the switch when it is closed, and then pass through the resistor, being reduced by the resistor, and then it enters the LED. And once it returns to the power supply again, which can be a battery, then the LED will come on. So current will only flow in a circuit when it sees a path to return to its source. That is one thing you should know when it comes to understanding how to manipulate current flow in a circuit, how to manipulate electron flow in the circuit. That's number one. Number two is that current only flows from a region of high potential to a region of low potential in a circuit. What this means is that current flows from points of high voltage to points of low voltage. So in this circuit, you can see that this point has 5 volts and this point has 2.0 volts. And you can see the direction of flow of the current. This green dots signifies current flow. And you can see the arrow pointing to the direction the current is flowing to. So the current in this circuit is flowing from the region of 5 volts to the region of 2.0 volts. And this 5 volts is greater than 2.0 volts. So current in any circuit will always flow from a region or a point of high voltage or potential to a point of low voltage or potential in a circuit. That's number two. Then the third thing we should know is that in a circuit, more current flow through the path with the least resistance. More current flow through the path with the least resistance. So let's pause this simulation and then let's create another branch of the circuit, because here we only have one branch. As you can see, we only have one branch, which is the branch from the switch to the resistor and back to the LED. But let's add another branch to the circuit and we will observe what happens. So I will pause the simulation and I will add a component to the circuit. I'm adding a resistor and I'm also adding an LED to the circuit. So I will flip this and I will also rotate this and drag this here and drag this here. And I will join this to this. I will join this to this. Excuse me. And I will join this to this. Now, we have two branches in the circuit. We have this branch that has a resistance of 100 ohms and this branch that has a resistance of 1000 ohms, which is equivalent to 1 kilo ohms. So we will simulate the circuit and we will see how current flows in the circuit. Remember, we are trying to demonstrate that more current tend to flow through the path with the least resistance. So we have two paths here. We have the path that has 100 ohms resistance and we have the path that has 1000 ohms resistance. So I'll run the simulation and boom, you can see from the current flow indication, you can see that in this direction, we have more current flowing than the current flowing in this direction. So in this direction, we have 29.6 milliamperes of current flowing through this direction, entering this LED. While in this direction, we have a current of 3.19 milliamperes flowing into this LED. This part that has more current has a resistance of 100 ohms, while this part that has lower current has a resistance of 1000 ohms. And in fact, you can see that this LED is not even coming on. But when we reduce the resistance of this resistor now, we'll observe what happens. So I'll reduce it to 900 ohms, then 800, 700, 600, 500. You can see that the LED is coming on as I'm reducing the resistance. And when I get to 200, you can see it is bright. All right. Now, you can see that current flow has increased in this direction or in this path because we have reduced the resistance. And you can check the figure. Here we have 29.6 milliamperes. Here we have 14.6 milliamperes as against what we had before that was lower than this value. So this goes to show us that in every circuit, the path that has the least resistance will have more current flowing through it, and the path that has the highest resistance will have the lowest current value flowing through it. So these are things you need to understand about the manipulation of electron flow. These are things you need to understand about current flow in a circuit, and they will equip you with the appropriate knowledge and skill to carry out your circuit design. Now, we've talked about understanding current flow in a circuit. Now, let's talk about the components. Here, I have, okay, let me return back to the circuit we had before. So I will delete this, and I will also delete this resistor. You see, when I was a kid learning circuit design, being enthusiastic about circuit design, when I was in primary school, I used to gather LEDs and batteries, and I will connect them. Now, it happened that sometimes when I make my connection, my LEDs will burn, and I couldn't figure out what the problem was. Well, I've come to know that the reason why I sacrificed a lot of LEDs then was because of my limited knowledge of the various electronic components. I never knew what is called a resistor, that a resistor will help reduce the rate of current flow in my circuit. Now I know that there's what we call current limiting resistor that you must connect to your LED in series to help you reduce the current flow to that LED, to avoid you having that LED burn out. So if you have limited knowledge of the electronic component, it's going to be a problem. You're going to find it difficult with your design. But if you equip yourself with the knowledge of various components and how to use them and how to place them in a circuit, you will go far in your design. Let us connect this circuit without a resistor and let us see what happens. So I've made the connection, I'll run the simulation, and I will close the switch, and boom, the LED is burnt, because all the voltage from this power source, which is 5 volts and 50 amperes that it can supply, 50.8 amperes it can supply, are all entering this LED, and the LED cannot hold it. What will it do? It will burn, it will damage. So your reasonable knowledge of the various components will help you in your journey to designing electronic circuits. Another thing we need to know about electronic circuit design is that we need to connect our components the right way. One thing is to know the components you need, and another thing is to know how to connect them. Take, for example, I will go back to the first circuit, so I'll add a resistor, and now I have this circuit. If for any reason, let me reduce this resistor to what it was before. Okay. Now, if for any reason I revert the LED, instead of having it in this direction, if I now have it in this direction, what do you think will happen? Well, we will find out. So this LED is a diode, and from our knowledge of electronics, a diode allows current to flow in one direction, especially diodes like the LED. It allows current to flow in one direction, which means it is polarized, which means it has a positive terminal and a negative terminal, which means you have to connect it rightly in the circuit, otherwise it will not work. Now, we have reversed the polarity, and we connect this here and connect this here, and then we connect this here. Now, I will simulate the circuit. I simulate, and no current flow in the circuit. Why? Because the LED is reversed, is connected in reverse order. And because it is an LED which only allows current to flow in one direction, current will not flow into the LED, and the LED will not come on. So if you know your components, you should also know how to connect them in a circuit, because if you connect them wrongly, you are not going to realize your desired results. Another thing you should also know about components is that you have to use the appropriate values. Okay, so let me revert to the previous circuit I had. So this is the previous circuit I had that was working fine. Hold on, let me remove this. Hold on. So this is the circuit I had before that was working fine. Now, the value of the resistor I have here is 100 ohms. If I should increase the value of this resistor to something higher than 100 ohms, the circuit may not work as expected. So let me run the simulation and let me increase the value of this resistor. Let me increase it to, let's say 5,000. Okay, let's say 5,000 ohms here. Let me say, oops, hold on. Let's say 5,000 ohms. Now you can see that current is flowing in the circuit, but that current is not powerful enough to energize the LED. So when you are selecting your component, you should be able to select the components with the appropriate values. If you select the components with the wrong values, you will not get your desired result. Here now, the current has been reduced to 671 microamperes, and it is not enough to power the LED. So when you're designing your circuit, you should select the components with the appropriate value so as to get your desired result. Because some of the circuits you design are automation circuits, and automation circuits requires some kind of timing. And when you are talking about timing, you need to work with precision. And to give you the timing you need components like capacitors and resistors to give you the timing. And these capacitors are numbered, they have their values. So if you use the wrong value, to give you the wrong timing. That is why you need to know the components you are using. You need to know them very well, know how to use them, know their values, and where to place them in the circuit. So these are some of the things you need to know as a circuit designer to prepare you to design circuits from scratch. You need to understand current flow, how to manipulate current in a circuit, and you need to also understand to a reasonable extent the various components we use in circuit design, how they behave, and how to use them in a circuit. I always use the soccer game or football game as an analogy to explain circuit design. So see yourself as a coach, you the circuit designer, and see your components as the players. See the rules of the game as the rules of circuit design. So as a coach, you should know the appropriate location and position to place your players. The same way as a designer, you should know the appropriate location to place your components. And you must have understood your players and your components before you even bring them into the pitch to play. And you should know the rules of the game. You should know the rules of the soccer game you are playing. You should also know, the same way you should also know the rules of electronic circuit design. So we have a lot to talk about, have a lot to do, have a lot to design, and we'll be doing that as we progress in this tutorial series. That will be it for today's tutorial, and this is just the beginning. I'm going to call this Introduction to Electronic Circuit Design. I will be creating more tutorials in this series, so to be updated when I upload the videos, kindly subscribe to my channel on YouTube, follow me on Facebook and TikTok, and please, if you like this video, kindly give it a thumbs up. Let us know your thoughts in the comment section, and as always, share this video for others to watch and learn. If you want to master or if you want to learn electronic circuit design and you want a one-on-one tutoring or a one-on-one coaching or training, you can contact us. You can reach out to us via email or send us a DM or leave a comment in the comment section about that, and we will respond. We are on a new series and we'll do our best to teach it in such a way that at the end of the series, you will have an intuitive understanding of how to design electronic circuits from scratch. Thanks for watching. Bye.